wondered how electromagnetic waves are produced? In today's class, we will be learning about the sources of electromagnetic waves. This is exquisite, and you are welcome to the class.
Okay.
I will start by making you recall some basic knowledge about charges.
Okay.
If a charge is at rest, that is, if it is not moving, then it usually generates an electric field around it.
Yes, I remember this.
If the charge is in uniform motion, then it generates a magnetic field.
Yes, I also remember. A moving charge produces current, which in turn generates a magnetic field around the current.
Great. And if the charge accelerates, then it generates an electromagnetic field.
How is this, Sensei?
If a charge is accelerating, then the current it produces will be changing, and so the magnetic field generated will also be changing. The changing magnetic field, in turn, generates an electric field.
Okay. I get it. A combination of the electric and magnetic fields generated is what gives us an electromagnetic field.
Exactly. A common example of an accelerating charge is an oscillating electron.
Yes, when an electron oscillates, its direction keeps changing, and so it keeps accelerating.
Correct. And because the electron keeps accelerating, it will produce a continually changing magnetic field. The continually changing magnetic field, in turn, generates a continually changing electric field, which in turn generates continually changing magnetic field, and so on. And the cycle keeps repeating.
Wow! I now see why oscillating electrons generate electromagnetic fields.
Yes. Do you realize that all electromagnetic waves are basically the same? They are similar in every way, except in their frequencies.
I am just beginning to realize it now.
Yes, radio waves, light waves, X-rays, and all electromagnetic waves are similar, except for their frequencies.
Okay.
So, the frequency of an oscillating electron is what determines the type of electromagnetic wave it will generate.
I see.
Radio waves are generated artificially by radio transmitter antennas. Electrons are made to flow back and forth in specially designed antennas, making them to produce time-varying electric fields, which generate electromagnetic waves known as radio waves.
Okay.
Microwaves are also similarly generated, but in antennas that are shaped to produce higher frequency oscillations.
I see, because microwaves have higher frequencies than radio waves.
Exactly.
How about the infrared?
The main source of infrared is heat or thermal radiation. This is still linked to the oscillation of electrons within objects that emit the radiation.
Does it mean that only hot objects emit infrared waves?
Not exactly in that sense. You see? Even cold objects like ice contain some amount of heat, and so emit infrared waves.
Okay. But warmer objects emit more infrared waves?
Yes, they do. On the other end of the spectrum,
we have X-rays and gamma rays.
Yes, the main difference between X-rays and gamma rays is how they are produced. X-rays come from electrons, while gamma rays come from the nucleus.
Oh, I see.
Then finally, I like to let you know that the sun and other stars do emit all of the electromagnetic waves.
Do you mean that the sun also emits X-rays and gamma rays?
Yes.
But those rays are harmful.
Yes, they are harmful, but fortunately, as the X-rays and gamma rays try to move from the center of the sun to the surface, they are absorbed by particles within the sun, which re-emit them as lower frequency radiations like ultraviolet, light, and infrared waves.
Oh, that is really fortunate. The sunlight would have been very harmful to our bodies if the X-rays and gamma rays were not absorbed.
Yes, the major part of radiation that leaves the sun's surface consists of light, ultraviolet, and infrared waves.
Better for us, but the ultraviolet waves could still be a bit harmful.
That's true, but the ozone layer in our atmosphere protects us from the harm of ultraviolet waves.
Oh, that's true. The ozone layer absorbs ultraviolet waves, and re-emit them as heat, thereby protecting us from the harm of ultraviolet waves.
Correct. And that's where we draw the curtain for this class. Give us a summary before we go.
1. Oscillating electrons are the main source of electromagnetic waves. The frequency of oscillation determines which electromagnetic wave is produced. 2. The main difference between X-rays and gamma rays is that X-rays emanate from electrons, but gamma rays emanate from the nucleus. 3. The Sun and other stars produce all frequencies of electromagnetic waves, but the X-rays and gamma rays are absorbed during the process of moving from the center of the Sun to the surface. The major part of radiation that leaves the Sun's surface consists of light, ultraviolet, and infrared waves. The ultraviolet waves still get absorbed by the ozone layer in our atmosphere before they reach us.
Great. See you in the next class where we will focus on the uses of electromagnetic waves.